Okay, hello and good morning to another webinar on the Steel Detailer. There were a few questions over the last couple of weeks with regards to some advanced modelling tips and how we can actually speed things up. This is sort of a demonstration of out of the box and how to think a little bit differently. So today I'm just going to cover something that you've probably never seen before, and yeah, stay tuned, I suppose. If you've got any questions, we've got everyone muted. The best thing for us to do is to just keep that off to the side, because too many voices will slow the internet connection down. I'll just close that off. Yeah, if you've got any questions, send them to support@thesteeldetailer. Yeah, we're underway. So what you can see in front of you here is a portal building that's being modelled, and with that we've got some connections that have been put in place. What I'm going to show you is the next step on how to produce models really fast so they can go into your project, and then we'll build an actual model so that you can see how the process is done. Alright, so I'm just going to zoom out and get myself an overall view of what I'm working on. And down in this area here, I'm just going to put in a whole complete wall ready to go, and I'm going to show you how to do that wall. Alright, so if we go into our TSD members, and with that in the members area we've got purlins and girts. Either way we can go girts or purlins in the menu, and I've got a complete wall here that has been modelled that I can drop into my project. Now this wall itself can grow in two directions. It can grow across the bottom and it can grow across the top. That means that when I snap it onto the horizontal line and the vertical line, it can grow in either direction. Now this is just an example. There are no equations in here, but you could set it up so that if your building grew, it would automatically add another girt and another set of holes inside everything, and you know, populate the right number of purlin bolts. So I'm just going to put that in, and as you can see, this is quite quick. Once you've modelled it, you can reuse it over and over again because it's coming out of the library. I'll show you how to upload it into the library. And we just wait for it. There it is, and it comes. Now this is a preset one that I've done. Okay, so this is a girt panel. Okay, so in a girt panel we've got our assembly which sits below. Now this hasn't been snapped onto the driving sketch at the moment. This has just been inserted, so it's pretty much just free floating. Okay, the only thing that's snapped on is the member sketch, which is across the bottom, which the Steel Detailer does for you automatically, and the vertical. Now in your girt panel you can put anything you like as far as girts go. I've just modelled up something that's representative of some bridging, which is just a channel in an extrusion that changes based on the length of the line and the centers of the purlins. I've created a pattern for the girts. Now if you go down into the girts, you can see I've got girt and purlin bolts, whichever way you want to call them, and we have GP brackets in place. That pretty much sort of just gives you a bit of an indication on what you can do and what you can put in. There is a pattern. I've got a header for my roller door, so I've got my purlin bolts there. Now these bolts are just representative of a purlin bolt. You can model anything you like. At the end of the day it comes down to how you model them and what naming convention and the configuration name. Okay, you'll notice they stick out past the nut and the washer. It's because I've just used the same bolt in all the scenario. At the end of the day, a purlin bolt is a standard purlin bolt, so it doesn't matter where the thread sits or anything in it. All I'm doing is capturing the actual bolt itself, so I can put it into a report. Alright, so as I said, you can put bridging in there already. You can put in roller doors, you can put in even door styles, windows, cut them all in and have them already GP bracketed. And this will all come into a bill of materials for you so that you can create your reports. So basically what I'm going to do is just run you through the process of how I created this and how it got to where it is. But I'm going to make it another one which is a little bit more simplistic. Okay, so with that in mind, I'm just going to close that one because I'm going to keep that where it is, and I'm going to add another one which is just another part of the model itself on this side. Right, before I do that, I've actually got to put some sketch lines in our driving sketch so that I can attach the next girt frame to it. So if I go into the frame sketch, which is down here, I've got a couple of lines there already, and I can go into my girts, and there's a base sketch which is already there which I can use. This is a double bay going into a single bay into a double bay, and I'm just putting that line in there. Now also on this wall, and depending on whether or not there is a plane there for me to work with, which it looks like there isn't, but I can work from the front plane, I can put another vertical line in place. Now if I look at the planes, that's the front plane there, and I know that that's the front plane because I did model this. I'm just going to put an extra line in at this point, right? And I want that line to match the length of this line. Now this is just updating the driving sketch so that I can snap on a girt frame. Okay, label my sketch so I can put it down in here, and in this case I can go south wall. It looks like there might be some south wall girts. Yeah, so I could have put my sketch in there as well, but in this instance I've just isolated it. So I'm just going to go vertical, member sketch leg, south wall. Okay, so that just names the sketch so I know where to go if I need to find it. Alright, so I've pretty much, just move that out of the road, I've pretty much just updated the sketch just for this instance, for this next set of girts that are going to go in. Alright, so now when I insert, I should actually isolate the frame. I've just done a rebuild and a save there. I'm going to isolate the frame so that I don't select anything else other than the frame when I insert. It's a good tip, a good technique. So you use the isolate component, which is this one, and that turns everything else off except the frame that I've got in view, and just hides it temporarily. I can always turn it back on by hitting exit isolate. Now if I go into my girts again, in this case we'll go purlins. Where are we? Go girts, TSD, pick that wall again. Now I've already created this, so I'm just going to show you, and I'll peel it back. I'm just going to create a standard row so that we can reuse it. As you can imagine, once you've got your library set up for these walls, you can pretty much populate an entire shed fairly quickly. Oh, and this also works for purlins. Certainly certain locations for purlins. If you've got lots of purlins you want to put in, you can put in a whole stack. Now this has got error in it. That's probably because it's a little bit different in its length, or there's a mate issue, which looks like. We're going to peel this back anyway and take out a lot of the stuff that's in it. So we're going to modify the driving sketch, and I'm going to roll back some things. So in here I've got patterns, which could be linked to an equation. I'm just going to delete the patterns, right? And there's a couple of girt issues which we can solve here in a moment. Because these are parts, we can actually go through and remove them. Now what I'm going to do is just make a dual bay, single bridging per bay girt arrangement. So with parts, we can actually delete the parts just using the process of selecting them one by one. So delete. And that removes the part from the file, and it also removes it from the database as well. What's wrong one? Parts, delete part. There's an enhancement request we could put in there where we can select multiple parts in one go and delete them one after the other. You'll also notice our GP brackets are in here as well. Now these GP brackets have been used elsewhere, so we can just select them and delete them out. Now you'll notice all the bolts, we can remove all them as well. So I'm just going to bring this back to the bare basic model. Now this particular GP bracket here is a non-standard GP bracket, which you can model up any kind of GP bracket and then have a fabrication drawing for it. With that I'll just use the parts again to delete them so that they're not as a file. Same thing again. With that in mind, I also have in here my toolbar for my delete parts, which is you just click straight on here and it'll take the part out as well. Now why not use SolidWorks, just standard deletion processes? Well, I want to remove it from the database, and I also want to remove it from filing, and that's the reason why I'm using this process. If you just simply delete it out of SolidWorks, the part will remain in the background, and you don't want that. So I'm just removing that girt because I don't want that anymore, and all the bolts and the fasteners. Okay, now bolts and fasteners themselves, I've just gone and created this off to the side. I'm just going to remove every single one because we don't want them clouding our modeling. So I'll just remove all them. Now what we're left with is a girt that's not happy because it's got holes in it that we need to fix for some particular reason. It's fallen over. We need to fix that girt. Let's find out where it is. It's obviously that one if we isolate it. Okay, so we've got a plane here that's fallen over because there was a trim at the end, based on the plate, on the connection that was there, and we just close that. Now we've got a girt that's just sitting there, no holes or anything in it. Okay, it's bare, and you can insert girt parts. If you create girt parts and upload them to the part library, you can insert them. In this instance, they're already there, so we're just going to stick with that. I'll show you how to do that in a minute. We've got some brackets here I need to get rid of as well that we're not using, and there'll be some holes in here that may fall over. Yep, that's what's happening. So we want to delete that part as well. I'm just thinking ahead. So going into here, and there's a couple of holes in this fascia that's been put there for the bracketry, plus there's cuts that have fallen over, so we just need to make sure that they're removed as well. That's for the roller door style connections. Continue, and we just delete them. So now we've got ourselves a purlin that's a fascia that's done. So we won't need to revisit that one. Alright, so now what we're going to do is we're going to change the sketch so that we have a full girt that runs across the bottom. So there's a set out sketch. So what we've got is we've got ourselves a member sketch, which is horizontal. We have ourselves a vertical sketch, which is vertical, and we have ourselves a driving sketch, which everything is associated to. So I can actually just go in and remove the components out of there that I don't want. In this instance, pretty much the roller door. Yep, get rid of that. The little return legs here, and I want to bring that over so that that sits there. Alright, now we've got 2 rows of bridging here. I'm just going to bring 1 row of bridging over so that we can reuse it. Okay, so I'm just going to remove the equals out of there and bring this over here, so now we've got 1 row of bridging there. And what I also can do, now you'll notice with my driving sketch I've actually got column center lines here, which I will snap on to the columns driving sketch, or the driving sketch at the beginning that we modified, and then that sets up the center so that if I was to change a bay, the whole lot would automatically update. So I'm just going to put in some lines here. This just sets out the equals componentry to center the bridging. Okay, so we make that equal, select these 2 lines, make that equal. Okay, so we've got our start. Now maybe over here on the right hand side I've not done this right, because what I've got to do is, this is going to be an end bay wall. I need to set it up so that I can flip it. So it means that on the left hand side at the other end of the wall I've actually got an overhang past the column so that the girts come to the end. I need to do the same thing on this side, so maybe the trick here wasn't for me to extend this up, so I'm just going to do that. You get that when you're modeling. Some things always change when you're going through the process of the design intent. So I'm just going to draw a line here and do a trim on all those lines, and trim component is under the sketch, so we just grab that, and you can do a power trim that just snaps all the lines. Okay, now I can bring that out to there. Okay, and now this line here, because it's on the end of the driving sketch, we need to move it inwards, because you'll find that that's what has to happen for the column, because the column won't go all the way out to the end. And this line here, right, can just be the finish line, and we'll just grab that and drag that to there. And if you find that you cannot select it and get a coincident, it means that the you have to rotate your sketch, because one sketch line is drawn on one plane and the other sketch line is drawn on another plane, and to actually select both of them at the same time, sometimes you have to actually turn it in 3D to get them. Alright, so This one here we need to trim because we want to make it equal to the column, so we'll just trim that. So now we've got a floating column sort of arrangement here which we can drag, and we need to make that line and that line equal if they've lost it, and they have. Whoops, I want to undo that, sorry, because we want to put a dimension on this so that it doesn't float around. Now you have to dimension these up, and then when you put them into your project you have to remove the dimensions if you want to snap them on. The reason that I say lock your dimensions in place is because when you go to insert this, it's going to grow and shrink and it can go all over the place. So the best thing to do is lock it in place. So it's really important that your driving sketches are locked. Okay. So now I've got myself a driving sketch that I can fiddle with, and you'll also notice that because of the changes that have occurred, the girt has updated its length and the bridging has moved across because they're attached to those sketches. You'll notice that in my sketch manipulation processes I try to not delete any sketches if possible, and I'll reuse bits and pieces of components, so that's a quick fix just out of habit. Okay, so now we've got ourselves a girt at the bottom, and we've got our bridging in each single bay, and we also have our columns that we can snap on to the driving sketch. It looks like that set out sketch is not fixed, it's not fully defined, sorry, and that symbol there tells me that it's still not fully defined. If I edit the sketch, there's something in there that's not fully defined. Now as I said, I prefer fully defined sketches, and I'm not exactly sure where that fully defined issue is not showing up. So I've actually got to go through my sketch and have a look. So I've got snap points at the ends. What's happening up the top here? I grab that, and you can actually just grab a point and pull it and see what happens, and it sort of gives you a bit of an indication. And by the looks of it, just looking at it, you might not see it on your screen. That's it there. Okay, it is highlighted blue on my screen, you can just see it. So now I'm going to snap that onto there, and that fixes that one. And we just go around and have a little bit more look. There's still some more here that are not working for us. Okay, they look alright. Just looking around here, looking for the snap points. As far as I can see, everything looks okay, but it's not telling me that it's locked. You grab lines, check to see if there's points that are occurring where they should be. Any other points that should be where they are. It should be a snap point on that one there. I don't know why that's not showing that. And that was it. It was that one point. Okay, so yeah, now I've got the sketch working. That means it's fully defined. It means now I don't have that symbol in there. Alright, so now I'm going to work on my bolts and put my bolts in. There are no brackets in this case, so I'm just going to remove that folder. So I've got my girts. Now if I go down into my girt, and you can go crazy with this as well, what I'm going to do is on the top plane I'm just going to put a sketch on there, and I usually set it up so that there is some rectangles on top, so I'm just going to go this way. Now this is for setting up the holes. Sometimes you do trim the ends off these things, and if you do put a sketch in there that drives another sketch, you'll find that it'll break. So sometimes it's not best to draw a center plane, and if you're going to change the section of the girt, I should mention this, that what I do, just out of habit, I create a center plane on two faces. So I select this face and that face, and I'll put a plane in. Now I've just hit my S key to bring up my shortcut. I hit the center plane. Now that brings the center plane in. So it means if I change my girt, the holes are always going to be in the center. So I'm just going to name that. So center plane, and then underneath the center plane we'll have our hole sketch, which I can name now even though that we have started it. Okay, so on our hole sketch. So what that means now is that if I wanted to, I can actually draw a line through the middle now in our rectangular boxes, and you only need to do one. You can actually make them collinear, so it means if the plane moves, so do your centers. Now this is a C150-12. In Australia, C150-12 is the name for a girt or a purlin. It's a cold rolled section. So in here we have for standard centers for our bolt gauges. Okay, so 60 for a 150, and in Australia you'll find out that as you go to 200 it's a 110. You can set up configurations so that every time you go to change your girt size, this dimension will change. Personally, I don't really like doing that. If I change the girt, I'll just go and change the dimension. It's just the same really. Also too, you'll notice that I haven't fixed this to the end because we've got to do a trim of 5mm as well. So I'm going to put that trim plane in as well, and I'm going to shift it up the tree in front. But what I want to do is just get the holes started, okay? And we can come back and lock this sketch down. So there is going to be a centerline of bridging, so I'm just moving that rectangle out there, and I'm just going to snap the next rectangle in. So that's in. Now that last vertical line is where a column line is. This is another bridging holes, and you'll find that I'm way off as far as the scales go, but that's okay because we're going to lock these into position in the girt when the time comes. So we've got column, bridging, and we need to come up to here, and you'll see that it snaps on, and we're still maintaining the 60 centers. Now this end we don't trim. We don't know what the dimension is, but we're going to lock it on, but we'll keep it there floating at the moment. Alright, so now that's just a centerline hole, so I'm just going to highlight over the top of this and make this a centerline sketch, I should say, make it for construction. So the whole thing is for construction. Now I'm going to make this a little bit more realistic. That's a bridging piece over there. Put that in the center somewhere roughly. And you'll notice the center hole, which is the one that's just come up yellow there, sort of gives you a bit of an idea you're close to the center. And then we'll just pull this one over here into the middle. If you're not careful, it'll snap on because there's it's a fair distance away and it'll look for a point. So if that happens, just click undo, and then zoom in so that you do not snap onto anything. You'll notice that happened. I ended up with red down there. Alright, so now we've got our center holes. What we want to do is we want to trim 5mm off this end because that's our clearance. You can set this up any way you like really. At the end of the day, this is how we're doing it. So I'm just going to put a plane on the end and I'm going to come in 5mm just to trim it, center it. Okay, and now I'm just going to trim that off. And to do that, if you go into the weldments tab under your command manager, if you haven't got the weldments tab, just right mouse click, command manager will show. If you right mouse click on a tab, then you can go here and select it and turn it on. Alright, so in here we've got trim extend. So we can select the member, select the face we're going to trim. And you'll notice there's little boxes that have come up. You'll see discard and keep. So we just hit the discard if it's automatic, and then that just trims that end off for us. So now we've actually got a trim that's in place. I can roll the bar back down again because what it's done is it's put the feature in front of the sketch. Now the feature is shown. I can actually select that plane, right? And if that plane moves, these positions of these holes will also move, and that's what you want. So if you're not using a 5mm clearance, you might want to use a 10. The holes will move when you update. Normally when you punch holes in purlins, there's always a 35mm punching straight in from the ends by stock standard. That's normal. Also too, you'll notice that the hole sketch is now floating. What we want to do now is put some holes in, so we'll just go up in here and select our features and go to our hole wizard. And you'll also notice with the hole wizard I've got hole set up. I'm using Australian standards. You use whatever standard you want. Drill sizes, diameter 18, usually an 18 slot. And I'm just going to go up to next on my hole. And if you click the positions tab, you'll start seeing that you can click on the corners and put your holes in. Okay. So we'll just put holes where we've got bridging in that case, and then we'll zoom across. And if you can't see, there is a control button that will allow you to, if you hold it down in your middle mouse button, it'll allow you to slide along. So you probably don't see it, but I'm just panning at the moment. And there's the other one. And hold my control key down, and now I'm just grabbing that one. Alright. So if you click the tick, that puts the holes in. Okay, so now we've got the holes in place. We can go back to the girt and we can lock it onto our driving sketch. Okay, now the girt itself, if we go in, you'll notice that this end has got a stock standard 5mm cut, 35mm in. We're not actually going to attach that to anything at this stage. We're just going to leave it as it is. You'll probably find that the column sketch here will go outside anyway, because the column's going to be out here in the center, 5mm off. Alright, so now I'm just going to line up my hole sketch. So if I select on the hole sketch, or if I go into the feature tree of the actual girt itself, and you'll see my hole sketch, and I edit that sketch, right, what I want to do is I want to line these up. So I want to select that line there, right, I want to select the end of that line, and I want to select that point. Now sometimes it's not easy to select the points because it's not clear. If you rotate around and get your line, whoops, I selected the line, I did it again, select the point. If not, worst case scenario, select the point first, make sure you've got that one, and then hold your control key down and then select your point over here. Now you can make this, I think in this case it might be vertical, but if you click the one, it'll tell you which one it is. It's definitely not horizontal, so as I said, it's vertical, so that lines it up. So now if that line on my driving sketch moves, so will those bridging pieces, okay, which is really good. Now I'm going to put the column one in so that column one matches. Select the point at the bottom, so that's got to be not horizontal. I did it again, whoops, third time's a charm. Don't want to do that again. And now we select this point, and I'm just going to hit the tick over here. I have to rotate this around so the point is exposed. Hit my bridging piece, make that in, so that locks that in. And last but not least, the last set of holes. So I just make that locked in. Alright, so now we've got our first girt piece that's going to be driven. Now what we need to do is put some holes in, some bolts, sorry. We've got bolts that we can put in here to set up a pattern so that the bolts will come in the project. Okay, we've got our bridging. Now you can at this stage create a pattern in there. So patterns are really easy. So under the girts, if we select the first one, I'm just going to break out the patterns. So I need to select a direction sketch, okay, and you'll see the pattern come in there in sort of like invisible, and then you click your tick, and that's the pattern for your girts. You can name your pattern to match your girts, so you can say that's my girt pattern. Now I like breaking my patterns out. It's up to you on how you want to model. I break them out so that if I wanted to modify a certain number of items, I can. In this instance I have to break them out because the bridging itself is a 3 pattern instance, whereas the girts is a 4. So I break that out. So I'm just selecting the girts. Selecting the bridging. So the bridging goes in as a pattern. So now I've got pretty much a girt wall without bolts. Now let's do bolts. On your SolidWorks screen, if you're not familiar with them, there's a design library, okay? Now I'm just going to show you something so that you can see. Now I've got my fasteners. Now I'm not using SolidWorks as fasteners because, hang on, I'll just accept that. I've just had to update that. Now I'm not using SolidWorks as fasteners. What I'm using is my own fasteners that come from the Steel Detailer. There's nothing smart about them. They're just there and they're labeled a certain way so that we can use them. So for us to add a folder inside our design library so we can simply drag and drop, if you click on this button, you'll see that if I click the fasteners folder and click OK, it brings in my fasteners. So now I can get access to my fasteners. Now in my fasteners, now that might not be clear, so let's just do that so I can show you what's going on. If I go into my C drive and go to the Steel Detailer, and in there I've got fasteners. That's the folder that I've just loaded in to my design library. So I can keep it off to the side and grab it whenever I need to. So now let's just bring that back out again, and you can push that in so that that's always in. Now as I said, I've got my fasteners and I have my M12 purlin bolt, which I can drag in and just drop. Now you can add smarts to your bolts so that they'll automatically snap into place. However, I have not done that, and you can if you like, it's up to you. If I grab the cylinder, grab the hole to which the bolt belongs to, and mate it in place. Okay, now you only need to mate one in place manually. Now, because this is a girt cleat, I'm just going to give this a 10mm clearance from the top face just to make it look okay. Alright, now my fastener itself is floating, so I just need to do a parallel mate on the front planes. So I've got a front plane of the whole wall and the front plane of the bolt, and that just locks that in place now, so that's fully defined. I can't move it. As I said, I like fully defined things. If I can get them fully defined right up to the last moment, I certainly will. Now I'm just going to save that. Now the purlin bolt itself is a part that's looking outside of the folder of this wall, girt wall that we're putting together, and we don't want things looking outside the folder. What we want is we want to keep the items in the folder that we're going to reuse. Now that item there should not be okay, that's the bridging, so just making sure that we've actually got the right items in our folder. So when we did all the deleting, all the files had to be removed, and it looks like it's left the files that we're really interested in. Alright, so now this is a virtual component. We need to make it a virtual component because all bolts in TSD are virtual. The reason for that is because we can filter on virtual components. So I've just right mouse clicked, changed it to a virtual component. Now it's telling me it's going to break all the links. Now a virtual component actually sticks the part itself inside the assembly, so there are no external files to deal with. I'm now renaming it. If you just click on it, you can actually just rename it and take the copy of out, so that you're stuck with the final M12 there. Now with bolts with TSD, we have a naming convention. If you simply just stick M in front, that's the name of a bolt. I know you could use B. We've used M as a letter to define the bolt. So when we do our bill of materials, when we do our lock, it picks up all the bolts. The name isn't that crucial for the reports. What the name is that's crucial, if you go into the actual bolt itself, is the configuration name. So I've got an M12 35 long purlin bolt nut and washer. That's the crucial name. Okay, you could have your custom properties as well match. It's up to you. If you want to do a bomb inside SolidWorks, you want this information to come through. So you see the same thing there, except that that's got a 40 in there. I have to fix that up so it's not 40. They should be 35. So we'll just make sure that we've got the right thing. So 25 and 10 makes 30. That should be 10 mil. And it's 15. So on this one, we'll just take off 5 mil, and then that'll make it so that it's a 35 mil bolt. That did nothing. And it depends on how this thing's been modeled too, by the way. If you double click on it, you can see that there is dimensions in there that we can fiddle with, and there's the 20 mil that we need to take 5 mil from. So that updates that. Now that should update the custom properties for the bolt. Okay, and it hasn't for some particular reason because it's getting it on its overall length. There's the length of the bolt there. So we need to take that off as well, 5 mil there. A bit of fiddling, but once we've got it, we've got the bolt right, so now we can use the bolt. So now that should be right in the custom properties of the bolt. And properties. So now we've got our 35. Okay, so that's the bolt, just updated to match. Now what we want to do is put our bolts everywhere. So in SolidWorks, if you right mouse click on your bolt, you can go copy with mates. Okay, let's start putting bolts everywhere. Distance and parallel, you want to make them repeat, and all we want to do now is just put bolts in. So we click the center, click the tick. Right, now the only bolts that occur in this situation occur at column locations where there's going to be a cleat. So we're just putting bolt there, and 2 more bolts. Bolt there. So you notice I pick the center cylinder face and then pick the bolt. Now, okay, so now all our bolts are in place. With bolts, we've actually got to exclude them from the bill of materials. The reason for that is filtering again. It's a TSD thing, and it gets picked up within the reporting, so don't worry about doing that. And I'm also going to place this into a new folder, and I call it fasteners. So now I've got all my fasteners in the right place. Okay. So the next thing for us to do is to pattern our bolts. So we need to select all the fasteners that are in that folder. And now we've got a direction. We've got to put 4 lots in, and now we hit the tick. It means that with every girt that's in there, we have bolts that are associated to it. Now we also need to do the same thing with our fascia. Now with the fascia, we've got to do a little bit more work around this because the fascia itself has got holes in the end, and we've got holes over here that seem to be lining up. We need to move those over so that they're stock standard 35 at this end. Okay, so we're just going to go in and modify this fascia. Now we need to check to see if there's any trims. There is one at this end that we need to take away. Now that'll make things fall over. not in this case, which is good. We want to keep that going all the way to the end. And if you accidentally delete something like I just did then, that plane there is associated to the sketch, and sometimes it will remove depending on how far down the tree. So now I'm just editing the sketch associated to the holes in the fascia. And you'll see in this one I've actually gone to the midpoint, which is an old method, because as I said, you take a cut and it can fall over. Now this is a C200 purlin, got a 110 centers. Okay. Now I've just pulled that away so that the trim doesn't affect, and we should be able to just remove that right end trim. Okay, and on the right end we want to take our standard stock 5mm to match the girt. So 5 is remembered, and we'll call this the left trim plane. Okay, and we're going to bring this up so that it's in front of our sketch. So just grab and drag, and now I want to trim it again, so I'm just going to select that. Select the body, make sure your face is occurring, and take away that and do not allow extension, and that does the cut. So now in this instance we can come back to the driving sketch, select the vertical and the plane, and if you have not got this in order, it will look a bit funny. I'm a little perplexed with that one because the holes actually, the driving plane comes after, and we've got some sort of okay, there's a collinear, so I'll just remove that relationship. Select that plane because that's the trim edge, make that 35. Okay, so we've got 35 from the trim, and then down the end, this has got to be floating, so we just got to make sure it's floating. It is, and that's our sketch floating still. Now I'm just going to bring the bridging pieces in, so looks like they're already there by the looks of it. We've got some other sketch in play. I'll have to have a look and see what they are. If there's no holes on it, we need to work out what they are. I think it's because we had double holes. Alright, so I'm going to sort of just skip through a couple of steps here because I am running out of space and I can only record so much video. Alright, so in this instance I'm just going to fix this up so that that's done. If I put bolts in there, it's the same sort of scenario as the girts. Now what I'm going to do is these links, I need to break the links because what I'm going to do is add this to the library so that I can reuse it. Okay, so I've got my links. I'm just removing the links in the relationships. Alright, so now for me to add this to the library so that I can reuse it over and over and over again, because this is going to be a common thing for people who do buildings, if I go to my TSD members and I go upload member, I select my filters, structural, girts, TSD, and I hit my tick. This does an audit to tell me that everything's okay in the model before it uploads it. Okay, it's just going through that audit right now, and if there's any issues it'll pop up and tell me. Hopefully there is an issue because I want to show you. Okay, now what this has done is there's a few bolts in here that are not right. Now I've seen this before. This is a bug within SolidWorks because what it's not doing in the patterns here, when you go to pattern, it doesn't exclude them from the BOM when you do a pattern the first go. Okay, we want to exclude our bolts from the BOM, and that was one of the issues that we have. Now what I'm also going to do, just for this, because I know that there's a little bit of a SolidWorks glitch in here, I'm not going to use the pattern for the bolts. We can come back and add those back in again. They are a little fiddly, and you got to play with them to get them to work. It's only just recently we've noticed this with 2013. So what we want to do now is we'll just upload again. Structural, girts, TSD, and that'll go through that audit again. Because I've taken the bolts out of the equation, it should upload it. No, it's still telling us that there is a problem with our fasteners. It's telling us that there is a virtual component that needs to be turned into a virtual component. Alright, this is new. We are looking at why this is doing this. Usually that is a virtual component. So for some particular reason the virtual component isn't being flagged. So in this instance I'm just going to take the bolts out and we'll come back and fix that up later. It's a bit of a pain. So I'm just getting rid of these fasteners. They are virtual components and they are in there. So now we can just upload this. That'll work. Structural, Gertz, TSD, and it should be fairly quick. There it goes. So that's uploaded. So now we've got it in our library. I'll come back with the purlin thing and confirm that there is an issue with it. Now, the same sort of scenario could occur on the end of this frame, so I'm just going to show you how to insert that on the frame so that we can reuse it. Obviously, this end is where we want to put our frame sketches. Alright, so we're going to put it on the end. Now, I can go in and modify the driving sketch that's there already, and you'll notice that that hasn't gone all the way to the end, so that was a bad move on my part, because we want that to go all the way to the end. Vertical, yes. Now I'm going to draw another line here. Right. Now the actual girt wall that we created doesn't actually suit that scenario. What it does suit is this wall, because of the way we offset it. Okay, so I'm going to place it on this wall. That line and that line. Horizontal. That lines that up. And on the end, there should be a plane on the end, a west, yep. Should be west wall plane. Doesn't look like there is a west wall plane. There's west wall girts, which is a bit odd, because there should also be a west wall plane. East. There's the east wall. That's right, because the west wall is the right plane. Alright, so on that plane I can draw a sketch. So I'm just going to draw a sketch on there. And I'm going to draw it up so that it's a vertical line all the way up there. And I'm going to snap that onto that point there. And I'm going to make this line equal to, this line here equal to that line. So I've just updated the driving sketch. And if you do your driving sketch right, every time you get to use it, it'll always be there for you to fiddle with. Now I'm just going to save that. Now what we're going to do is insert the girt wall that we just uploaded to the library. So if we go to our members and go purlins and girts and select on girts, you'll notice our wall is in our library. Now we can make these pictures look nice and we put text all over them. We cover that in another webinar, or if you look at our online tutorials as a customer, there's demonstrations on showing you how to do that. If we select the horizontal line and the vertical line, we can hit the tick and that'll put a whole new wall of girts in for us, based on what we just uploaded to the library. You can change the centers, you can change the patterns, but the whole process is linked to those two lines. And you'll notice that we have to do some snapping, because the girts themselves are hanging out over the edge of our frame, and we want to bring them in. And in this instance we don't need the fascia, so you just go and remove the fascia out of there, and you'll have to add another girt line in there, but the idea is to get 90% of the way there so that you can reuse them. Now I can come back and fiddle with that. That's just attaching sketches. Also too, if I want to duplicate, so I've got this object over there and I want to bring it over here, I can do the same thing. So I'm just going over and updating the sketch so that on this side, if I rotate that around, I've got the same thing happening again. Now this is based on the bays being the same. Obviously if the bays change, you would not duplicate, you would create a new set. And the reason for duplicating is so that you can pick up the girts and total them. So I'm just going to just modify this sketch again. So on the base girt sketch, and you'll notice the direction to which I'm actually drawing to, left to right. Okay, and I'm just going to snap that and that under a relationship. Oh, there is already a line there that I can just snap straight onto, which makes it a little easier. And I need another sketch on my, now this is a north wall, so I can put another sketch line from there up to there. Now I want that line there because this is the outer line to match. Now just make sure I've got the right line. I do. And I'll make them so that they are equal. Okay, come back and label those sketches later. As I said, I'm a little pressed on room for recording. Alright, so now I've got something I can snap my girt sketch onto for my duplication. I've just done a rebuild and a save. Go back to my members area and I can use the duplicate member. So if I select one of the members that are inside inside that girt wall, and I can pick the bottom line, and that will replicate that and put a duplication of it, into that position. So now if the girt wall changes on the other side, the girt wall on this side will change as well. Now snapping on, because I've designed it that way, my driving sketches associated to this, as you can see, are set up. So I can actually go in and snap on my columns. So I'm just going to do that. Now I've got dimensions in here that set certain things up at play. I can make that and that collinear, okay, and I've got a dimension here that I remove. I can make that and that collinear. Now this is all about parametric behavior, so that if a client comes along and changes something, everything will update automatically for you. Now it looks like I'm off grid there for some reason. I'll just check my member sketch down there, because that doesn't look like that's right by looking at it. But anyway, I can snap that onto there and there, make that collinear. So that what that'll do is that'll set up all the holes on the girts so that they are right. Now I need to go down and have a look at my member sketch here, because something's happened. I go to my girt wall, which is this one, and because we detached it, of course, to upload it, it's not attached, so we need to reattach it. Remember that process. Not collinear, it's got to be equal. So now the driving sketch is updated, and our holes and everything line up with our columns. So if a bay changes, that automatically updates. Our bridging will automatically update now, because the bridging itself is centered, and everything is now snapped on apart from our vertical sketch, which we need to snap onto our driving sketch. Okay, a bit more fiddling with getting the girts right, but it certainly makes a lot of difference when you actually do drop in a set of girts and you've got it preset, so it means that you can save some time. At the end of the day, you want to run the girt and purlin automatic drawing creation process over the top of this. You want it seamlessly, so you want to make it quick. Girts and purlins can take a lot of time when it comes to modeling big structures, but you simply want to make it easy so that you can simply insert them just as we have, as I've just demonstrated. Now that pretty much concludes the demonstration for today. If you've got any questions, please send an email to support@thesteeldetailer, and I would love to thank you for your time, for being online today, and yeah, enjoy the rest of your day if it's the start of your day, and if it's not, then see you next week. Enjoy your week, guys. Bye.